So this is lesson 9.4 in intermediate algebra, and we're going to continue on with our radicals. I love radicals. And what we're going to do is we're going to add and subtract them. Now, there's a couple rules here on adding and subtracting. If we have a radical sign, we can add them to other radical signs if they have the same index and everything in here is exactly the same. If the indexes are different and if the numbers inside here are different, you can't add or subtract. Now in multiplication, the indexes have to be the same, but it doesn't matter what's inside here. You can still multiply them, but in addition and subtraction, all that has to be the same. Alright, so that being the case, let's look at some examples. When we have 5 square root of 3 minus 4 square root of 3 plus 6 square root of 3. Okay, the indexes are all the same, 2's, and the numbers inside the radicals are the same. Alright, so we just go ahead and add and subtract the numbers outside. 5 minus 4 is 1 plus 6 is 7. And you're done. 3 square root of 8 plus 5 square root of 18. Okay, so it appears that you can't add those. But if we reduce our radicals, we might be able to do that. So, the square root of 8 is the same as 2 cubed. And square root of 18 is the same as 3 squared times 2. 9 times 2. So, if this is a 2 out here, if my index out here is a 2, and I have a 3 there, how many times does this 2 go into this 3? 1 time with 1 left over. Okay, here, I've got a 2 here for my index, so how many times does this 2 go into this 2? 1 time with none left over, so the 3 goes away. So I have 6 square root of 2 plus 15 square root of 2. Now everything is okay, and I can add those and get that for an answer. Okay? So, when they don't appear like you're going to be able to add or subtract, you might be able to if you reduce. So let's look at example 3. So first of all, you're going to try to simplify each radical first before you try to combine them with other ones. And this takes a little bit of time because you have to look at each term here and simplify. So we're going to simplify this. 7 5 squared times 3 gives me 75 xy cubed minus 4y 2 squared times 3 xy. Okay? Now let's look and see what we can pull out. Well, I have a 2 here and a 2 here, so 2 goes into 2 one time, so I can pull that 5 out, and there is nothing, whoops, there is nothing left in, no 5's left. Okay, I've got a 3 here. I can't do anything with that, so it stays there. I've got an x there. No exponent. Can't do anything with it. 2 goes into 3 one time with 1 left over. Okay, so when I put these together, 35y square root of 3xy. Okay? Now, let's look at this one. Minus my 4y, just leave that alone. Okay, 2 goes into 2 twice, so I can pull that 1, 2 out. And I can't do anything with the 3, the x, or the y because they have no exponents. So let's go ahead and change this to 8y. Everything in there is the same as there, so I can take 35 minus 8 and get 27y square root of 3xy. Okay, so remember when you combine, the stuff in here doesn't do anything. It just stays the same. The only thing you add and subtract are the numbers outside of the radical sign. Alright, so let's go ahead and do, where are we? Example 4. 10 cubed root of 8a to the fourth b squared plus 11a cubed root of 27ab squared. Alright, so let's simplify what's in each one of these. And what I want to do when I simplify is get them into the prime factors. So 2 cubed, 2 times 2 times 2 is 8. A to the fourth b squared plus 11a cubed root of 27 breaks down to 3 times 3 times 3. Alright, now we're going to look and compare this exponent with each one of these. So the 10 stays. Make myself a little bit of room. 3 goes into 3 once, so the 2 comes out. 3 goes into 4 once, with 1 left over. 3 doesn't go into b squared, or into 2, so we don't do anything with that. So we have 20a square root of ab squared plus. Now let's work on this one. Give myself some room. 3 goes into 3 once, so I pull the 1, 3 out. And nothing here, nothing here. So those stay there. This then, here, will become 33a. So let's go ahead and write that as 11 times 3 with the a. So 20a plus 33a is 53a square root of ab squared. Oh, I'm sorry, cubed root. Those are all cubed roots. Sorry about that. That gets confusing, doesn't it? Okay, so let's look at example 5. We have cubed root of 3 over 2 plus 1 over the square root of 3. Alright, so what we do here is we simplify each one. That one is simplified. This one we're going to multiply by the square root of 3 over the square root of 3 because we can't have a radical in the denominator. So that is the same as that. It's just in better form. Okay, now one of the things that we have going on here is we don't have common denominators. We can't add these without common denominators since they're fractions. So the common denominator is 6. So how do we make that a 6? We multiply top and bottom by 3. How do we make that a 6? Top and bottom by 2. So this becomes 3 square root of 3 over 6. This becomes 2 square root of 3 over 6. So these two gave me this, and these gave me that. Alright, so now I can add these. Oops. Equals. Add my numerators. 5 square root of 3, and then the 6 you don't add because it's in the denominator position. And that's it for example number 6. And that's all we're going to do as far as, or example number 5. We're not going to do example number 6. So you should be good to go with these. I'm going to just do 1 or 2 from the homework and then set you free. Alright, so this is a problem set. This is number 26 if I wrote it down right. So let's go ahead and see if we can simplify each of these. Alright, so this one simplified. We can't do anything with the inside. And this is an 8, by the way. So we're going to just put our x out here and a 4th root and see if we can do anything. The 5, there's no exponent on there, so it stays. No exponent on the x, so it stays. 4 goes into 8 twice, so we bring those two y's out of there. And that's it for simplifying that one. Let's simplify the next one. Y. Leave ourselves some room here. And we have a 4th root. So we're going to have to take this 405 and do the factor tree. So let's go ahead and do that down here. And that is going to be 5 goes into it 81 times. And then 9, 9, 3, 3, 3, 3. So 405 is 3 to the 4th power, right there, times 5. Okay, so let's get rid of this so I can write there later on. So 3 to the 4th power times 5. And then I've got x to the 5th, y to the 4th. So let's go ahead and simplify that in blue. Alright, we can take 4 goes into that 4 once, so I have 1 3 out. And then 5 stays there. 4 goes into this one time with 1 left over. And this one goes into this one time with nothing left over. So this ends up giving me 3xy squared, 4th root of 5x. Alright, let me write this over here too. Okay, now let's look at this one. Let's do this in yellow just so you can tell that it's a different problem. So this is going to be plus. So I've got y squared and the 4th root of, let's see, 2 times 2 times 2 is 8 times 2 is 16 times 5 is 80, x to the 5th. Sorry. Alright, let's make this, let's do this so you can see what I'm doing. That's just kind of lame. Alright, so again in yellow. Y squared, 4th root of 2 times 2 is 4 times 2 is 8 times 2 is 16 times 5 is 80. Okay, so this is going to be 2 to the 4th, 5, x to the 5th. Okay, 4 goes into 4 once, so we're going to bring that 2 out. There's no exponent on there, so the 5 stays there. 4 goes into 5 once with 1 left over. So we're going to write this as 2xy to the 4th, 2, okay, golly Gary, come on, 2xy squared, sorry my eraser quit working now that I did something weird, 4th root of 5x. So this rewritten just looks like that. I just moved things around. Alright, sorry this is just kind of messy. Hopefully you're following what I'm doing here. Alright, so let's go ahead and write. We've got this here and this here to add. So x, y squared, I'm just writing everything together, 4th root of 5x plus 3x y squared, 4th root, 5x plus 2x y squared, 4th root, 5x. Alright, now I'm going to take this, this, and this and add it. And I can do that because they all have xy squared. So 1xy squared plus 3xy squared is 4 plus 2 is 6. And then the 4th root of 5x doesn't change. It just kind of drags along with you. Alright, so anyway, all of that, and that ends up being our answer. Okay, so if you can follow that, you can do anything in the world. And that's it for problem set, or lesson 9.4.